Welcome back, everyone. This week the students dive into an engine with a dead miss, and they also get back to work on our 48 Chevy project. Thanks for tuning in. This 98 Tahoe came in with an engine misfire, which the students quickly diagnosed as cylinder 2. We also diagnosed it as being a mechanical problem. In other words, it wasn't ignition or fuel related. So our next step was to do a cylinder leakage test on that cylinder, which you've seen us do before, to determine where the leakage was. And by doing that, we introduced compressed air into that cylinder while it's on compression stroke and see how much leakage we have and where it is. On this particular engine in cylinder 2, we had 100% leakage, and it was coming from the exhaust. So they're going to see the students pull this apart and see what they found. The first step is to remove the valve cover. Then the intake plenum comes off. Then the distributor comes out so the lower intake can be removed. Next, the cylinder head gets detorqued so we don't damage the head by warping it. We can use an impact gun to remove the head more quickly. I put a piece of cardboard behind this valve so you can get a better visual of how bent this valve really is and the reason why it wasn't sealing. I'm going to explain to you how this valve got bent. This vehicle had sat for many years before someone came along, stuck a battery in it, and tried to start it. The problem is that a vehicle that sits for many years develops varnish inside of the engine and can cause components like this valve to stick. And apparently, the last time it had been shut off, it stopped on the exhaust stroke in cylinder 2 where the valve was open as far as it could go. Then when someone went to crank it, the piston came up and smacked the valve that was stuck open. The correct way to start an engine that's been sitting for many years, it's a little time consuming but you won't do damage to it, is first pull the spark plugs out, soak the cylinders with a little bit of oil, and then most importantly you want to rotate the engine over by hand using a ratchet or a breaker bar or something at the crankshaft. The reason is you'll be able to feel how much resistance the engine has as it's rotating, and then if there is an issue with some resistance, in the case of where the piston would have touched this valve, you would have felt it, or this person would have felt it, and then they could have backed off of it just a little bit and then figured out, okay, which pistons are on top dead center at that moment, which in this case would only have been 2, and they would have been able to deduce exactly which cylinder it was, and this could have been fixed without removing the engine, or in this case the cylinder head. We could have taken off the valve cover and that particular valve, and we could have freed it up, put it all back together without removing the cylinder head at all. Here we're compressing the valve springs so we can remove the keepers so we can get our bent valve out. There you go. You saw where the exhaust valve was bent from the piston hitting it, cylinder 2. We have since acquired a new valve that we're going to install. But instead of machining the seat to get these two to match, what we're going to do is just use some valve grinding compound and lap this one in place. And I'll be able to tell the pattern that it's leaving and whether or not it's going to create a good enough seal so we don't waste time actually machining the seat. If we were going to recondition the entire head, that would be one thing. But just putting this one valve in so we can get the engine running correctly, this is all we need to do. We got our new valve with our valve grinding compound on it. We're going to put it into the guide, get it pushed in like so. Then we're going to take our lapping tool, suction cup in and put it onto the valve, and then we're going to take and go back and forth like this with a moderate amount of pressure, lifting periodically, moving it, doing it again. Oops. Lift it again, move it, and keep doing this. And you actually, I don't know if you could tell the difference between when we first started, it was a little more aggressive sounding. Now it's much smoother. So it is doing what it's supposed to do. And then what we're going to do is we're going to take the valve out. What you don't want to do is touch the head of it. You want to grab it by the stem, pull out, because we don't want to interfere with where the seat is going to be. So, or what we're trying to see in the face of the valve anyway. So I'm going to take and clean it off. Okay, and then we can actually see where it's making contact. It's definitely hitting too high. It's too close to the margin. So we are going to have to cut this seat a little bit. This would seal, but we don't want it that close to the margin. There's a little bit of a line there, but for me it's not enough. So we're going to cut this seat just a hair to get that contact pattern a little bit lower on the valve face. We're set up to machine our seat. I've got our pilot in place for our tooling. We're going to set this to 46, so we're going to use the 46-degree side. Put that in like so, and I'm able to do this one by hand. We have a machine to do this if we're going to do them all, but since we're just doing one valve, or one seat rather, this will work fine. So a moderate amount of pressure while I'm making the turns, and you can see where we're getting a lot of cutting there. You can see where we've cut quite a bit off of that, and actually it's going to make it sit higher up on the valve, so we're going to come back with a different angle here shortly. But you can also might be able to make out there's a couple of lines in this that I'm not real happy with. So we're going to go with the 46, a little more. Again, I'm not putting a lot of pressure on it. Okay, now I'm going to come back with the 31. Looks like it's hitting a little high. Maybe not. Let's find out. I'll take the one cut to... Yeah, we're hitting a little high. I put the blades down a little closer to the center so it's not hitting as high up on the in the seat area. Feels a little better, so now we'll cut the 31. And that's going to take some of that top off of that 46. And again, it'll bring the contact pattern for the valve down a little bit. Take the guide out. With our seat cut at the two angles of 46 and 31, I'm going to take a marker. We would normally want to use like some machinist blue, some kind of a dye, but this permanent marker works fine. You can see where we've got the permanent marker and it's a little spaced out along the valve. So what we're going to do now is put it back in, smack it a couple of times where it's seating against the seat area itself. Hopefully you can see that line in the black where it's actually making contact with the seat. It's a little below the margin now, so that's pretty much where we want it. So what we can do is clean the valve up. We'll use our valve grinding compound to seat it, put it back together, and then install the head back onto the truck. With the seat cut to match our valve, we're ready to put it back together. I've got the valve installed. We're going to put our valve spring on it. We're going to put our retainer. Then we'll take our valve spring compressor tool. We're going to capture the retainer on this side and the head of the valve on the other side. We'll compress the two. Then we'll take our two keepers, get these installed onto the valve. Now most of the time you need to put grease on them to hold them in place. We're just doing this one. I think we'll be fine. So if you can't keep them in place, then I would definitely recommend using grease. But I think we're going to be okay. So we're going to ease it off very gently. The spring will come up and capture the keeper. And now I've got a nice closed valve. It's going to create a seal for us. so we can get this head put back on, and once it's all back together, we'll get it fired off, and should run good.
We want to get all the old sealer off of our bolts so they don't affect our torque setting.
With the surfaces all clean, we're going to put on the new gasket. And with the head finished, we'll put the head on next, clean up the bolts and get it torqued down.
I'm adding sealer to the threads of the head bolts per GM's recommendation.
Good.
We had to cut the ends off of the EGR tubes so we could remove them with a socket because they were rounding off. We'll replace the entire tube.
Cool.
Here we're cutting the back part of the tube so we can get the fitting out of the exhaust manifold.
All the way through? All right, pull the pipe out.
Now we're heating up what's left of the one in the back so we can get it removed.
I'm only going to be able to heat maybe half of it at best. Just have to hope that's enough. All right, you about ready? We have the new gaskets installed on the engine with sealer front and rear. Now we're ready to set the intake manifold back on. Take your time. You're good. It's important to go straight down with it so we don't disturb the sealer until the lower intake hits the engine. Yep, got one right there.
There you go. Oh yeah. That's the third step, right?
Third step's 133, right?
I'm installing the new EGR tube.
The reason we had to replace the EGR tube is because we couldn't get it removed without damaging the fasteners. They were stuck into the intake and to the exhaust pretty tight. So we had to cut both ends off of them, which is pretty common, and then use a socket on it along with heat, which you saw, to get these things removed. And then we had to install a new one in the process. EGR stands for exhaust gas recirculation. What it does is it connects from the exhaust manifold to the intake manifold, and at certain times it will allow exhaust gases to enter the intake manifold where it mixes with the fresh air and it dilutes it so that when it goes into the combustion chamber, it actually lowers the combustion temperature. And what that does is it reduces oxides of nitrogen being emitted into the exhaust.
We're installing a new seal for our steering box.
This is something you've seen the students do many times. We're making our own gasket for our power steering box.
Perfect.
shaft first.
The shaft he's screwing in is the adjuster for the preload for the bearing, but we're just going to snug it for now. The steering box back together, the student's going to be adjusting the end play in the shaft. You can see the movement there where the two tapered bearings are. So we're going to tighten the adjuster now until we get that free play out. Next time on Bulldog Builds, we'll have more of that Tahoe engine put back together and ready to start. We'll get more work done on our 48 Chevy project, and we'll see how much more work gets done on that Chevy Nova hood. See you next week.